right, welcome to Intro to Python, class number 5, where we're going to talk about reading and writing files in Python. So we're going to go ahead and jump into our Jupyter Notebook, so our IPython notebook file here. We're on class 5, and this is where Python starts to get really useful. We get to start to see how we can play around and modify and write to files and read content from files. So we can start to bring in data from other sources rather than just having to generate math equations and things on our own. So the first thing we're going to do is we're going to create a file. We'll just call it myfile.txt. So I can just click this little plus sign here, and I can create a text file. And the first thing I'm going to do is I'm going to rename the file. Call it myfile.txt. And you'll see that it's put it into our folder here. I could also, just the same, could do the same thing if I just grab my my desktop here. We'll bring over, go to my Python class file. We got our Python files, and here's where I have all my Jupyter notebooks. And you'll see that it's just a file on our regular Explorer window. I could just as easily have right-clicked here, said new text file, and we'll just say myfile2.txt. And just as soon as I save it there, you'll see it'll pop up over here. So this is just showing us what's in our Explorer window here. We can just put some text in here. This is line 1. We'll copy that, and we'll make ourselves a couple of lines here. Oops. We'll say this one's 10, 9, 8. Three, 2, and 1. We'll go ahead and hit Control S, and as soon as I hit Control S, you'll see now that dot went to an X, which means it's been saved. Anytime I make a modification, even if I had a space, you'll notice that the dot turns into a solid gray dot. That means the file has not been saved. So I'll hit the backspace, and we'll get Control S, and we'll see the file is now saved. So if I close the file and open it up, you'll see that it's got the same contents in it. So let's go ahead and see how we're going to open that file in Python. We're going to create a file variable. We'll call it the name file. We could call it anything we want. We can call it my_file. Remember, variable names have to start with a letter or an underscore. And after that can contain letters, numbers, and the only special character it can contain is the underscore. So we're going to call it myfile. And we're going to equate it to opening a file. And as long as we're in the path, in this case, our Jupyter notebook, which is day5.ipython notebook, right here, you'll notice as soon as we're in the path of the same file, I don't need to give it the entire path. I can give it the relative path of where I'm located. So I'm going to call this one in as a string, because we're doing quotes. We're going to call this my file. And we'll call it .txt, because that's the full file name. And then for now, just understand that the R right here that I'm passing in as a string, remember, it starts and ends with a quotes, it's a string. So we're going to call it R is for read mode. So I can read the contents. And I can do it with a single quotes. It doesn't make a difference, but that gives us the ability to open a file in read mode. So just to show you what that looks like, if I come here and let's we'll go ahead and open this. So we'll go ahead and run this line of code. And you'll see how it ran. I have the number 1 there. Now if I go back to my Explorer window, and we go to our Python class, because the file's been opened, Python now has a handle to that file. If I go to our Python files, and I go ahead and try to delete, if I right-click and say, let's get rid of this file, because Python has a hold on that file when we opened it, it says, hey, you can't delete the file because it's being used by another process, and it actually even tells us what process. So it's saying opened by Python. So once the file's opened, it can no longer be modified. I mean, it can't be deleted from us, right? So we have it in read mode. We've got a hold on that file until I close that file. And we'll talk about closing a file here in a minute. But now that we have the file open, we can go ahead and do some things and read out of that file. So if we go ahead and use our myfile variable, and I'm going to hit the dot, and if we hit the tab button, we should get the IntelliSense, tells us what we can do with that file. And so we can say, oh, well, I can read from it. And read reads the entire contents of the file as a string. So let's go ahead and read. And we'll just call it file contents. And we'll even tell it that it's a string. So we'll just say str like that, right? So if I run that, we'll go ahead and hit the run button. And so now you see it says it's been run. Now this variable file contents string contains everything that was in that file. So let's go ahead and create a new code block here, and we'll see if we can just print it out. And we'll run this one. And there we go. We got everything that was in the file, so all 10 lines that are in that file. So that's how we can read the contents of a file, starting from the beginning, getting everything through the file. Or I could read it line by line. It just reads a single line from the file. So we'll go ahead and try that. Method next. So we'll come down here and we'll say my_file dot read line. So I got a variable now called line str, and it's equal to the first line of our file. So if I go ahead and print that out, we'll see what line stir has in it. Oops, I got to get back to, let's go ahead and, since I've read the file, what it did is, think of it as a cursor. There's a cursor in the beginning of the file. So as soon as I open the file, that cursor is right at the beginning of the file. But as I opened the file and read through the whole thing, it's kind of moved that cursor along. So if I go, let me explain this in a little bit better detail. Python files, open up my file, over here. So see how they got a blinky line right there? When I hit the read, it read everything and then put the blinky line, that cursor right there. So now when I do read line, it's trying to read everything from that cursor onward in the file, and nothing exists in there. So let's go ahead and see if I can add some text in there. So we'll say 11, 12, and 13. Actually, yeah, we'll skip 11. We'll say 12, 13, and 14, just so you can show that we can skip lines as well, right? So I can put enter and not have that in there. So now what happens when I do the read line? Does that give me anything? No, because I guess it kind of moved it to the end of the file. What we can do is we can close and reopen the file. So we're going to copy our first line of code. Before we open it, though, let's go ahead and close this file. And what this close is going to do is it's going to basically free up that file so Python doesn't have control of it anymore. And then right after that, we're going to reopen it, and it'll move that cursor back to the beginning. So we'll go ahead and run this, and now you can see we got line 1. If I ran this again, because the cursor's been moved, and I do that same print statement as well, what you would expect is to get line 2 because that cursor's moved. Every time I run this, if I run it again, I get line 3, then 4, oops, then 4, then we do it again, we get 5. So it's moving that cursor along of that file. And you can actually set that cursor too. We'll talk about that, I think, in next module, but my_file, we hit that dot sign, we hit tab. You can see there is a, somewhere in here, seek. I think it's the seek function is where, let's see if it gives us any IntelliSense on that. I gotta remember how to do that, so we look that up. File, move, read pointer to start of file. Oh, I forgot to add Python in there. Yeah, you can use the seek method with an offset of 0. We'll reset our position in that file. So right now you'll see that if I run this again, I should get line 6, right? If now I run this, let's run another one, and I run back to the seek of 0. I basically reset the little cursor all the way back to the beginning of the file. And now I can print out the next line. It should print out line 1. And there we go. So that's what the seek does. It brings us back to the beginning of our file. So you see, if I read it as read, I get the whole contents, and it moves that pointer all the way down to the beginning of the end of the file. I could seek it back to the 0, and then I could do the things like read line by line and move that pointer or that cursor to the end of the next, or the beginning of the next line, to the end of the one line, to the beginning of the next. That's what read line does. Read lines gives us all of them as a list. So that data structure that we learned about already, bringing it in that list. If I use the word read lines with the plural, that gives us to it right at the beginning. If I put that seek at 0, and then we get all the lines in the file. Now we've seen some cool stuff that we've already done in the class with data structures and with loops and some other functionality. So let's go ahead and see how we could, what kind of contents we can do. I'm going to close the file and reopen it, which is going to bring that pointer back to the beginning. And we're going to go ahead and use that read lines method. And I hit the tab to autocomplete for me. And I'm going to look for read lines, plural. And it's a method call, so we open and close that. Now we got to give it a variable name. So we'll call it lines list. And we'll put it in a variable called lines list. Now we're going to go ahead and run that through one of our functions, or one of our looping mechanisms called the for loop. So we're going to say for, we'll give it a variable name of line in our lines list. If I can spell there, hit the colon, and after we put the colon, remember we indent 4 spaces, and now we can print it out each line at a time. So I'm going to go ahead and do this. And then just to show you that we're printing on the next line, we'll just do print. And we'll put our own little 3 stars just to show you that each line, after each line, it's going to be a line of 3 stars. So this is line 1, 3 stars, line 2. So you can show that we're doing this line by line. I could also even show you the data structure of this if we go ahead and do a print. And then I want to do line list, but I want to do it as the type. So we're going to go ahead and pass it in as a variable to our type function. And that, so this is our type function, which gives us the data type of whatever we pass into it. So we're passing in the line list. And then we're going to go ahead and print that out to the screen. So we're going to, just to not confuse us, let's go ahead and comment out some of this stuff here, so that all you're going to see is the data structure type that line list is. And you'll see that it is, in fact, the list data structure. And that's why we're able to iterate over line by line. So line list is the variable we defined here. Line is the variable that we called in our loop variable, that every time it goes through the list one time, it's going to put the individual line in the variable called line. Now this is something that when I can structure whatever way I want. I could call this var list or var line. Whatever I want to call this variable is my choice. Just as long as I reference it when I'm printing it there. So it's not like I had to have the word line or anything. I could, any variable value that I want to give here is valid. I just have to make sure that I reference it in my list or in my loop with that same variable that's defined item by item in this list. So there we go. Showing you how that works. So that's pretty much what I want to cover for this topic on just opening and reading files. Next module, which we'll take a quick break and jump right into, actually no wait, we're not going to keep going. So we're going to talk about writing files, and then we'll talk about the various modes. So yeah, we still have some more to get done in this module. You've seen how we can write or read to files. Now let's go ahead and write to a file. All right, what I want to do now is close our file. So we have my file. So go ahead and close it. Okay, so now if I go to this in our Explorer window, because I've closed it, I can actually have the ability to go ahead and try to delete it, and it's gone. So now my file has been deleted because Python no longer had that hold on that file. I can undo that with Control-Z, and you can see I can bring back my file real quick. Okay, so once the file is closed, the operating system has full control over it. Now I opened it, the last time I opened it in read mode. So let's do my file again. This time we're going to open it as a string, give it its name of my file.txt, and we're going to open it in write mode. Now I'm going to do it like this for intentional, right? So I'm going to do it as a string. But what does it do if the file exists? In this case, my file does exist, and we're opening it in write mode. The contents will be completely overwritten. So let me show you what my file looks like again, just so we can see my file. You'll see I have lines 1 through 14, skipping line 11. The second I go ahead and open this file, I run this code, oops. Sorry. I'm a goofball. It's the file object that has the open capability, and I have to assign it to my variable, my file. So there we go. What am I doing here? File. Oh, it's just open. Goofball again. There we go. That's what I want. My file is the variable. Open is the method I'm using to call that file. Now we've opened that file, and because we've opened it, we've destroyed everything that's inside of it. And now if I open it, you'll see that it's completely blank inside. So if I open a file in read mode, I can see the contents. If I open it in write mode, it erases everything that existed there to begin with. So just make sure that you understand that. It'll blow all the contents away, but it does allow us to write into the file. So let's go ahead and see how that works. We had the read lines, the read line and read lines for the read. What do we have with writing? So if I do my file dot and I hit the tab button and I go down to the W's, I have write, and I also had write lines. So let's go ahead and see what this looks like. So I can write, this is line 1, and if I go ahead and run that, you'll see that I've written it to the file, but not really. So if you actually open up that file, and I don't know why I keep closing my thing here. If I open up my file, you'll see that it's still blank inside. This is a byproduct of speed. We want to make sure that we are doing things efficiently and fast. Writing to disk is a slow process. So what happens is we actually write to RAM, and then when we close the file, we take what was in RAM and move it to the disk. So we only have to do that one time. Otherwise, writing to files, every time I wrote a line, would create that I/O connection to the hard drive, which is a slow process. So we really like to do writes, a bunch of them in memory, and then one time move it to the hard drive. We can circumvent that with the ability to do what's called flushing a file. And if I do the IntelliSense with the tab button, and you'll see that there's a flush command. So what flush does is it says, I don't care that you're not supposed to write until I close the file. Go ahead and write the contents that are currently in memory to the disk right now. So if I hit this flush, actually let's do this flush on its own line, so not rerunning the same code that I ran twice. We'll go ahead and do this as its own line of code. And let's recap 1 second here. We'll open up my file, see that it's blank. Okay, I'm going to go ahead and run this line that flushes. I'm going to reopen up my file, and you'll see the content has actually been written to the file, but it's still in protected mode because it's still been opened, so I can't delete the file. If I try to delete it, you'll see that Python still has control of it. So that flush, what it does is it takes everything in memory, pushes it down to the file, doing that disk I/O operation. Even though it's slow, it's like hitting Control S. If you're typing a Word document and your power goes out, until it last autosave, you're going to lose all that content. That's really what flush does. It's kind of like the Control S. When you're typing a document, you hit Control S to save it. Flush is doing that. So you might want to periodically flush the contents. But if you're doing a loop and you're writing a lot of contents to a file, you may not want to flush until you've completed that loop, just to save some disk I/O, because that can be a slow process. Okay, so I've written stuff. I can write lines. So that's the next thing. Let's add that. So let's create some lines. Remember, to create a data structure of a list, we open and close with square brackets, and let's do a bunch of strings. So we can say line 2, comma, separate those, and we'll do a single quote 1, line 3, double quote 1, 4, and that should be good enough. Now we're going to go ahead and write the lines to a file. So we'll say my file dot write lines, and then we're going to pass it in our list data structure. So we got our lines data structure. We'll go ahead and pass that in. We'll go ahead and run it, and we'll check the contents of the file. We haven't flushed it, so we'll see that it should just have that line 1. Now we'll go ahead and flush this file. So we'll go ahead and run that flush command. Take a look at what we've got in our file now. And there we go. We got line 1, then I did line 2, line 3, and line 4, and I didn't put a breaking new line character, which I should have done. So let's go ahead and fix that. We're going to do lines, well, we're going to copy this, create a new block of code, paste it in here. We're going to do lines 5, 6, and 7. But this time we're going to do a special character called \r\n. I'm going to copy that. And let me explain that here, what that does. So back in the day we had printer or typewriters before we had computers, and they had what's called a carriage return. That would literally spin the typewriter thing one line. So if you're typing on a line, you'd spin it one line, so it would start now, all your text would go to that next line. So that's called a carriage return. But to bring the head of that line back to the beginning of your paper, that was that's what the carriage return. The line feed got us one line. The carriage return would bring us back to the beginning. So the \r gets us to the beginning, and then the \n gets us that next line. Now, modern, we always just assume we want to go to the next line at the beginning. So we could just do \n. But as historical, I've always done \r\n. You've got to be careful though, because in a file, both those characters get saved. So if you're doing a comparison and you're looking for a new line character, you may only be looking for \n. So if you do the \rn, just do it consistently throughout everything, or you can just use the \n. That's kind of more the norm these days. I've seen more just \n, but historically I've always done \r\n. All right, so go ahead and run this, and then we'll go ahead and write the lines. We'll go ahead and flush the lines as well, so we can look at how that looks on our file. Go ahead and run that code and reopen it. And you'll see now, after line 5, I did that \rn, it gets me to here. Line 6, \rn, gets me to line 7. And then now you'll see I even have that new line character. So after line 7, you'll see how it's now down there. And so that's what that \rn gave me. It's brought it to the next line all the way to the front. And we'll go ahead and close the file now that we're done with it. And I just want to do that on its own. I don't want to write those extra lines of code again. So I'm going to go ahead and run that by itself. You'll notice this time I'm actually doing a lot of their own little code blocks with this little plus sign. And that's because if I were to just add that line of code to close, I would actually run these lines of code again against that file. So it'd actually write 5, 6, and 7 again, and I didn't want to keep doing that. So I'm putting them on their own little code blocks so I can run just that one line of code. And that's why you can see me add a lot more of these code blocks on this time than other times. Because most of the time I just overwrite what I've done before. It's no big deal. But in this case, it'll overwrite to the file and just keep appending to, and I don't want to confuse you on what's going on. I only want to write to the file one time. And so you'll see I've added a lot of code blocks here. All right, so you've seen us how we closed files. I don't really even need to cover this topic, but it does close the pointer to the file. So now that I've closed it, I no longer have a hold of it in Python. So if I actually hit delete button, you'll see that it can delete the file. No problem, Control-Z, bring that file back. But that's what the close does. And you'll also notice if I didn't flush, the close by itself does a flush automatically. Whenever you close the file, it's going to take everything in memory and push it down, do the disk I/O, write it down to the file, and then go ahead and close it. So by closing the file, it's an implied flush. Take everything out of memory, move it to the file that's supposed to be there, and push it down into the file. Now it's a lot to open the file, and you got to remember to close the file. And what happens if your code crashes halfway through and we don't and we forget to close the file on an error kind of thing? Python's made this new concept called with. And this is a really interesting way to manage files. And this is actually the preferred way to do it. So it's considered a best practice to use the with, because it's going to create a block of code, just like we do in a for loop or in a function where we get that colon at the end and we do the four-line indent. With the with, though, the nice thing about that, as soon as we get outside of that space indent, it automatically flushes and closes the file for us. So we don't have to remember to open the file and close the file. We use a with statement, and that with statement will actually open the file, let us modify, either read or write, and then from there allow us to just do whatever we want to do, and it'll automatically close the file for us. So let's go ahead and take a look at what that looks like. We'll just say with. Let me see how I got to remember how to do a with open. It's been a while since I've done a with open. Okay. So we're going to say with space open. We're going to give it that same string path to our file. We're in the same directory. If we're not in the same directory, what I could do is give it the absolute path. So I could copy this and give it the full path to my file. So with open, and I got to give it the mode. So in this case, I'm going to do with R for read mode. Then I'm going to say as, and then I'm going to give it the file name that I want, the variable that I want to hold this. So in this case, we were calling it my file. So I'm going to keep with that context. So I hit enter, you'll see I'm tabbed in, or I moved in 4 spaces. So this is a little bit of a crazy syntax from your perspective, probably, because you've always seen we define variable names on the left side of our code. This is the one time we actually put the variable name using the as statement on the right hand side. So you may have seen that when we did imports, when we did import numpy as in p. That as gave it as a variable name, and that's what we're doing here. So we're opening the file just like we did before, that same open statement that we see right here, right? But we're using that open statement in front of that with a reserved keyword called with. So with, then that same open statement, then we use another reserved keyword called as, and we give it a variable name. So now from here, I can use this variable just like I would before. So we're going to say for line in my underscore file dot read lines, open close parentheses, colon, indent 4 spaces, and we'll go ahead and print out the line. Go ahead and run that, and you'll see this is line 5, new line, line 6, new line, line 7. And now why do we have 2 new lines here between these different files, or between these different lines? Because this read lines, this print statement, automatically adds a new line every time we do a print. But we've added the new line character in our file as well, so the print is printing the new line plus its own new line. And that's why you see these 2 new lines between the actual line of print. That's a little thing here. We could tell printline to ignore that. We could just say end equals and tell it to not do anything on the end. And then it'll do our single new line character that we generate. So that's why you have a line between each one of those. That's the one that we generated, not the one that the print statement gave us. So just showing you how that works. The other thing I want to show you, since I used the with open, as soon as this block of code ran, it leaves the scope of the with statement and actually closes the file for us. So if I go to our folder here, and I can actually delete this file, no problem, because it's no longer controlled open by Python interpreter itself. So whenever we use the with, it's going to automatically open the file in read mode in this case, since we told it to do read mode, do what we want to do, and then close the file for us automatically. Now if we go into write mode, remember write mode is going to delete everything in the file, so we can't really can't we use the read lines anymore. Let's go ahead and, you know what, let's leave this as read, Control Z that. Let's copy this little bit of code. We're going to do it again this time. But this time let's add it to this one. What happened here? Let's add a block code here. We're going to say write mode. But the next thing we're going to do is we're going to create our own lines. Lines equals. I'm going to create a list data structure. We'll do four lines. And I'll do 2 of them with double quotes and 2 of them with single quotes, just to show you that it doesn't matter. We'll say line 1, put a space to be nice. Line 2, 3, and 4. And we're going to go ahead and do our backslash in. We're just going to do backslash in this time to show you how that it does the same thing as a backslash rn, but this is just how you'll typically see it. In most code these days, you just see backslash in. Okay, so now that created the lines. Now we're going to say for line in our lines variable. So now we're looping over our variable that we created with 4 inputs. We're going to, instead of printing it out, we're going to write it to the file. So my file dot write, and use our IntelliSense. We're going to say write, and we're going to say line. Again, so we've opened the file with using the with open command. So with open in write mode. We've got a variable now assigned called my file, which is a pointer to a file, and since we opened it in write mode, it's deleted everything in all the contents of our file and put us right at the beginning. That cursor is now right at the beginning of our file. Now we've created a data structure called a list with 4 items in it, 1, 2, 3, 4, and then we're going to loop over each one of those line by line and write it to our file. Then once our with open goes out of scope, meaning we come back to this section here, that with is going to say, okay, flush that file and go ahead and close it for me. Go ahead and run this. And if we open up our myfile.txt, you'll see that we have line 1, 2, 3, and 4 in there for us. All right, so that is the basics of file operation. We can read and write files. Next module, we'll get into a lot more detail where you can see the different modes that we're going to play around with. So go ahead and take a quick break, and I'll catch you on the flip side, and we'll learn about the different modes in file operations.